Okay, I'd like to talk about the graph of an exponential function. It's important to remember on an exponential function there are four basic components to an exponential function. The input variable, x, the output variable, y, the initial value, and the factor. So when I look at a few exponential functions, let's start off with f of x equals 2 times 1.2 to the x. This function has an initial value of 0, 2. Now, every time I increase my x value by 1, I'm going to end up multiplying my y value by 1.2. So when x is 1, y is going to be 2.4. When x is 2, y is going to be 2.88. When x is 3, y is going to be 3.456. When x is 4, y is going to be 4.1472, and my function goes off in this direction and as well over here in this direction. Now, if I change my initial value but I leave my factor the same, let's take a look at this function with an initial value of, let's call it 1, but keep my factor at 1.2. Now, so I start off when x is 0, y is 1 with my initial value. And this time I'm still going to multiply by 1.2 for each additional x value. So y is going to be 1.2 when x is 1. And then y is going to be 1.44 when x is 2. And then y will be 1.728 when x is 3. And then 2.07. And what we see is the basic same shape of the function, just basically being sliding up and down as we change the initial value. Now, if we were to change the factor, we end up with a very different situation. Let's start off still with the original y equals 2 times 1.2 to the x. So we basically have a graph that looks like this, just a rough graph. And now I'm going to change the factor and leave the initial value the same. So again, when x is 0, y is 2. Nothing changed there. However, now when x is 1, I'm going to multiply by 2. 2 times 2 is 4. And I'm going to do that again. 4 times 4 is 8. And I'm already off the picture. If I go the other way, I'm dividing by 2 and coming in like that. So we end up with a much, much steeper curve. Now, this is for a growth function. We can also examine the same situation for a decay function. So this is making the factor larger. Let's look at what happens when the factor gets smaller. Let's put in a half as a factor. In this case, I'm still starting off at 0, 2. But now, when x is 1, I'm going to take the 2 times a half and get a 1. I'm going to take 1 and multiply it. Every time x goes up by 1, I'm going to multiply by half. So x goes up by 1, and I multiply this number by a half, by a half, by a half. Going in this direction, then it's dividing by a half, which is the same as multiplying by 2, so it becomes very steep. And again, if you kind of look at it, this has the largest factor, a smaller factor, and the smallest factor. So as that factor decreases, this end is going to be pulled down. When you have a graph of an exponential function, you can use it to solve equations. For instance, let's look at f of x equals 100 times 1.07 raised to the x. We would like to find the x value when y equals 200. Now, you can graph this by hand if you'd like to, but of course if we want more accuracy, it'd probably be smart to use our calculator. First thing I'm going to do is start by pushing the y equals button and entering our formula, which was 100 times 1.07 raised to the x. So now I have my equation in my graph. I'd like to set up a window. First thing we need to think about is what's happening with this graph. I realize that this is an exponential function. My factor is larger than 1. I'm starting at 100 and I'm going to get bigger. So I'm going to set my window. If I'm starting at 100, that means it's getting bigger. It's going to have x is 0 to somewhere in the future before it gets to 200. I'll just start off with 20 as a good beginning place. Scale, it doesn't matter. I choose a 0 scale. Now the y minimum value. You can choose 100 if you'd like, or you can choose 0 if you like. But the y maximum, I need to see when this graph reaches 200. So I'm going to put 250 so I clearly see when the graph reaches 200. And I'm setting my scale at 0 because I don't like to see the little hash marks. I'm now going to push graph. And we see our function. It begins out at 100 and it's going up exactly like we expected. Now, this function clearly goes past 250 before I run out of x values. If it did not, I would have to adjust my x values. In this case, I'm simply going to use the trace function on my calculator, and I'm going to go back and forth using left and right until I get as close as I can to 200. When x is 10, I'm below 200. When x is 10.21, I'm below 200. And now I am above 200. So I get pretty accurate. It's between 10.21 and 10.42. Maybe around 10.3 is pretty accurate. And again, I can play with my calculator and get more and more accurate if I'd like to. 10.25, 10.22. And as you can see, I can just, with trial and error, get pretty accurate. So, all I'm doing is using my graph to read the value where y reaches 200, or as close as I can get. In this case, I'd put my answer as around 10.24. Again, a graphical approach to solving an exponential function.